We live in a world dominated by the internet. From social media to online banking, we rely on it for almost everything. Ever wonder how it all works? It's like magic, but instead of spells, it's all about connections, protocols, and configurations. Don't worry, you don't need to be a tech whiz to get it. This isn't just for the computer geeks. Understanding the basics helps you make informed decisions. Choosing the right internet plan, troubleshooting problems, even just impressing your friends with tech trivia, it all starts with knowing the lingo. We'll break down complex topics into bite-sized pieces. Think of it like learning a new language, the language of the internet. By the end, you'll be navigating the digital world with confidence. Ready to dive in? Let's unravel the mysteries of the network together. First stop, how do we even access this thing called the internet? It's a question that might seem simple, but the answer is layered with fascinating technology. It all starts with an internet connection. This connection is the lifeline that links us to the vast digital world. You know, that cable snaking out from your wall or that Wi-Fi signal you're always chasing. These are the gateways that open up the internet to us. Remember dial-up? The sound of screeching modems and waiting forever for a web page to load? That was then. It was a time when patience was a virtue and every click felt like a gamble. Today, we have faster, more reliable options. The evolution of internet technology has been nothing short of revolutionary. DSL came along, offering decent speeds over existing phone lines. It was a significant upgrade from dial-up, making the internet more accessible. Then cable internet burst onto the scene, using those coaxial cables originally meant for cable TV. This brought even faster speeds and more stable connections. Fiber optic, the current speed demon, uses pulses of light to transmit data at blazing fast speeds. It's the gold standard for internet connections today. It's like having an information superhighway piped directly into your home. The speed and reliability are unmatched. Satellite internet beams down connections from space, a lifesaver for those in rural areas. It ensures that even the most remote locations can stay connected. And let's not forget mobile internet, allowing us to stay connected on our smartphones and tablets wherever we go. It's the backbone of our on-the-go digital lives. Each connection type has its pros and cons. Whether it's speed, reliability, or cost, there's a lot to consider. Speed, reliability, and cost vary widely. Some options are faster but more expensive, while others are more affordable but slower. Understanding these differences empowers you to choose the best option for your needs. Whether you're streaming, gaming, or just browsing, there's a perfect connection out there for you. Now imagine computers talking to each other. Sounds strange, right? But in the digital world, this is a daily occurrence. Every time you browse the web or send an email, computers are having a conversation. They communicate using a special set of rules called protocols. These protocols ensure that the data being exchanged is understood by both parties. Think of protocols as languages. Just like humans need a common language to communicate, computers need protocols. The most important one for the internet is TCPIP, which stands for Transmission Control Protocol/Internet Protocol. This protocol suite is the backbone of the internet. It's the foundation of the internet, ensuring that data gets delivered reliably. Without TCP/IP, the internet as we know it wouldn't function. TCP is like a meticulous postal service. It ensures that every piece of data, no matter how small, reaches its destination. It breaks down data into packets, adds addresses, and checks for errors upon delivery. This meticulous process ensures data integrity. UDP, or User Datagram Protocol, is like sending a postcard. It's faster and more efficient for certain types of data transmission. It's especially useful for things like streaming video, where the occasional lost packet doesn't matter as much. This makes UDP ideal for real-time applications. But how do devices know where to send these packets? This is a crucial part of the communication process. That's where IP addresses come in. These addresses act as unique identifiers for each device on the network. Each device connected to the internet has a unique IP address, like a digital home address. This ensures that data reaches the correct destination. Without them, data would be lost in the vast expanse of the internet. IP addresses are essential for routing data accurately and efficiently. Section 4. Finding the right door. We've got our data packets and their destination addresses. But what happens when they arrive? That's where ports come in. Think of ports like doors to different applications or services running on a device. Each port is assigned a specific number. For example, port 80 is the default port for web traffic. When you type a web address into your browser, it automatically adds 80 to the end, telling the server to send the requested web page to your browser. Port 443 is used for secure web traffic, the kind you see with HTTPS in the address bar. It encrypts your data, protecting it from prying eyes. And what about email? That usually uses port 25 for sending and port 110 for receiving. By using different ports, devices can handle multiple requests simultaneously without mixing them up. It's like having designated entrances for different departments within a company. Section 5. Networks, big and small. So far, we've focused on connecting individual devices to the internet. This is essential for accessing online resources, communicating with others, and performing countless tasks that are now part of our daily lives. But what about connecting multiple devices within a home, office, or across the globe? This is where the concept of networking truly shines, enabling seamless communication and resource sharing. That's where network configurations come in. These configurations determine how devices are interconnected and how they communicate with each other. The most common type is a local area network, or LAN. LANs are typically used in smaller, localized environments. It connects devices within a limited area, like your home or office, allowing them to share resources like printers, files, and even internet connections. This makes it easier to collaborate and share information quickly. Think of it like a small neighborhood network. Just as neighbors might share tools or information, devices on a LAN share digital resources. On a much larger scale, we have wide area networks, or WANs. WANs are designed to cover broad geographic areas. These behemoths span cities, countries, or even continents. They are essential for connecting distant offices of a corporation or for providing internet access across large regions. The internet itself is a prime example of a WAN. It is the largest and most well-known WAN, connecting countless smaller networks together. It connects countless smaller networks together, creating a global web of information. This interconnectedness allows for the rapid exchange of data and communication on a global scale. Now let's talk about how devices interact within these networks. The way devices communicate can vary based on the network model in use. In a client-server model, a central server, like a powerful computer, provides services to other devices, called clients. This model is common in many business environments. Think of it like a restaurant, where the server takes your order, request, and brings you your food, data. The server manages resources and ensures that clients receive the information or services they need. In a peer-to-peer model, all devices have equal status. This model is often used in smaller or more decentralized networks. They can share resources directly with each other without relying on a central server. This can be more efficient in certain scenarios. It's like a potluck dinner, where everyone brings a dish to share. Each participant contributes and benefits equally. Each network configuration has its advantages and disadvantages, depending on factors like size, security requirements, and budget. understanding these differences is crucial for designing an effective network that meets your specific needs. Section 6. Staying connected in a connected world. Congratulations! You've journeyed through the fascinating world of internet connections, protocols, and network configurations. We've covered a lot of ground, from the screeching days of dial-up to the lightning-fast speeds of fiber optic. We've explored how TCP/IP acts as the language of the internet, and how IP addresses and ports ensure data gets delivered to the right destination. But this is just the beginning. The world of networking is vast and constantly evolving. New technologies emerge, old ones are refined, and our reliance on the internet continues to grow. By understanding the fundamentals, you'll be better equipped to navigate this ever-changing landscape. Whether you're choosing an internet plan, troubleshooting a pesky Wi-Fi issue, or simply impressing your friends with your newfound knowledge, these concepts are essential tools for thriving in a connected world. So go forth, embrace the network, and stay connected.